last speaker for the day, John, who is I know, John, you are currently in the West Coast and it's like almost 2 a.m. for you. So we will not keep you up for so long. I would request you to start your presentation. His talk, everybody, would be using K8s to deploy security services in a hostile world. He is a senior security researcher at Google. John, over to you.
Hi, can everyone hear me?
Yes, absolutely. We can hear you and see the slides as well.
Excellent. All right. So as mentioned, I'm going to talk about how we use Kubernetes to deploy security services to some of our on-site assets. Before we get started, an administrative note: these views are not necessarily those of my company. They are my views and based on largely personal experiences. A little bit about myself. As mentioned, I'm a senior security engineer at Google. I work in the security for mergers and acquisitions team. We take care of enhancing the security of the companies that Google buys and try to raise the bar on the security that they came in with to try and make it even better than it was. I've been doing this for 12 years or more, mostly infrastructure security. And the final disclaimer is, caveat here is that I didn't know anything about Kubernetes when I started this project, and I still regularly claim not to know anything about Kubernetes. So we've got a few acquisitions that we deal with on a regular basis. There's, by a few, I mean a couple of dozen. Not all of them are completely integrated into our Google sphere all the time. So we have to have some way to deploy tooling to them. So this is not necessarily about how we specifically do this for acquisitions, but this is a way that we have determined to deploy security tooling without having to worry about scaling assets manually. Doing anything manually in this environment is a recipe for disaster, and we need to make some trade-offs between perfect security and better security. So we're not necessarily striving for 100% perfection. We want to make sure that we cover most of the large bases, and we go from there. So we use Kubernetes because we use a multi-cloud kind of environment. We've got different assets all over the place. So Kubernetes is like the one common thread that we have that can not only support all the cloud platforms, it can support on-premise deployments, it can support scaling our nodes for us automatically. So it kind of meets all of our needs. So when we were first starting to try and figure out what we were going to do, we had regular tooling deployed on top of regular compute hosts. So we needed a web proxy or something. So we would deploy a web proxy. And then we saw there was a lot of traffic going to that particular web proxy. So we would deploy another web proxy and so on and so forth. There'd be a lot of back and forth between us and these other entities to say, like, how many users do you have? How do you provision hosts? You can provision them for us, or we can provision them. And then we would need to watch to make sure that we had enough bandwidth and enough host load to be able to take all of the traffic they were sending at it. So scaling was kind of a big deal, but also the need to deploy more tools rapidly. Instead of the development process around creating tooling for individual needs, we need something we can deploy rapidly and deploy to everyone and have it work the same way. So we came up with a pretty quick plan. We wanted to abstract the problem away because we have so many different types of deployments. We had to make some tactical decisions about which knobs to expose. Kubernetes obviously has a lot of knobs. There's a lot of config you can do. You can do pretty much anything you want to do, as it's like infrastructure as a service, sort of. So we needed to decide what we could abstract away and what we needed to absolutely hard code. Then we needed to use those abstractions to come up with our own business logic. We don't have time to look into a bunch of different nuanced configs. Everyone can't have a different set of tooling. We need everyone to have the same tooling configured to their needs, but managed the same way. And then we need to eliminate as much of that drift as we can. So once we've deployed our tooling, we don't want the configuration to drift outside of the bounds of what we've deployed any more than the knobs that we've provisioned. So we containerized some pretty simple services to get started. We did a quick SSH proxy and a web proxy. We built in some sidecars to be able to do OAuth authentication on both of those, and another sidecar on the HTTP proxies to be able to do Acme cert renewal. All these things run in parallel so that we don't have to worry about updating certs. We don't have to worry about rotating credentials. All that's done for us. We have a DNS server with our own RPZ zone, and we've got some servers to do formatting and shipping of logs. So all those were pretty standard use cases for containerization. Turned out to be reasonably easy to containerize, and they run on Kubernetes pretty well. So the cloud setup process is where it actually really gets interesting. We are using the implementations of Kubernetes that have been provided by the different cloud providers. So GKE, EKS in Amazon, AKS in Azure. And as it turns out, all of those things are just a little bit different. So what they've all done is abstracted some more of the internals of Kubernetes to suit the cloud provider that they are hosted on. So you'd use different backend storage, obviously, in Google than you would in Amazon. So they've written their offering to meet those needs. That made everything just a little bit different. We needed to write abstraction layers inside of Kubernetes to be able to do the file storage hosting on the different clouds. There's a lot of different setup steps as well. We had originally started using the different API calls for the clouds, and then the different offerings for things like CloudFormation, Deployment Manager, but those got unwieldy to manage really quickly. So we switched over to Terraform eventually. Terraform made it pretty easy to abstract all those things away. We still do need to maintain different configurations for our Amazon and our Google configurations, for example, though, because they are still considerably different. All right, so we created our containers, and we got all of the containers plumbed into the Kubernetes YAML files. We decided to stick with YAML for our backend storage because that is what kubectl uses. Kubectl is the client you use to manage Kubernetes clusters by hand. So all of the stuff that we've created to manage it with our automated process is also able to be read into kubectl to manually interact with the clusters as well. That was a conscious design decision we made so that troubleshooting would be easier. We've got some simple text configurations for the folks that are spinning up these clusters to be able to configure that gets parsed into all these different files for them, so they don't necessarily have to become familiar with all of the YAML and all of the different knobs that you can have in Kubernetes. So a lot of that's abstracted. They make a couple of quick changes to a file, and all of that data gets replicated from our internal job out to the different clusters that we manage. And this isn't managing 1 or 2 clusters. This is managing tens, if not hundreds of clusters, all at different sites. So we've got to make the connection out to the site. We've got to do the configuration in the cloud-specific fashion. And then we've got to return the status, obviously, so we can monitor it. We've defined a lot of the different feature sets that are available. So for replicas, we've set a max and a min because we want to make sure that we have a minimum availability, but we don't want cloud costs to blow out of control. We've got health checks so that our load balancers can know which nodes to add or remove from the pools. And we've got different pull policies for when we should update images to make sure that we don't terminate existing connections, but also make sure that we're patching regularly, because the ability to patch smaller packages that are containers was actually a large impetus behind why we did this. So the most complicated part of the whole thing is that job that I mentioned that pushes the configuration from our internal clusters out to the external clusters. That's got a couple of different aspects to it. It not only updates the containers, but it forces our new workloads to install. It removes no longer used workloads. We've got a process to shard data that gets sent into the config maps stored in etcd inside of the cluster. So that's a separate job that runs so that we can push files that are larger than 1 meg into the cluster. And we also have a different job running to monitor the state, because all of the different cloud providers also have different monitoring tools. This was actually not super easy because of the differences in implementation. I already touched on a couple of those. An interesting example would be that when you do a cluster stand-up in k8s, it doesn't automatically create nodes for you. It creates the cluster, and then there's a separate call you need to make to create nodes to add them to the cluster. In GKE, it creates the cluster and it creates the nodes and adds them to the cluster. Neither one is necessarily better than the other. There's a lot of advantages to having the flexibility, but also a lot of advantages to having the nodes automatically added. It's just something you have to be aware of when you're standing up clusters, so that you don't see that your cluster was created, everything's successful. Why can't I serve any traffic? Well, because I don't have any nodes. There's some differences in load balancing. There were some recent changes to, I don't remember which cloud, one of them that it couldn't serve UDP load balance traffic for a while. That's since been fixed as the version of Kubernetes gets upgraded. And there's a lot of, Kubernetes is actually pretty fast moving. So from the start of the project, probably about 2 years ago to now, the entire feature set has been changed. We have a lot more functionality available now than we did when we first started. So some of the things that we had written code to do are no longer applicable because they've been automated. So finally, where's the project now? We've actually launched it to our internal beta process. We are looking to add different cloud providers all the time. So as the needs arise, we're able to pretty quickly spin up the ability to do this in different cloud environments. We're looking to add a lot more like RBAC policies to our clusters so that we can give read-only access to folks that need to monitor the clusters, but give more access to people that need to manage the clusters. So that, and we are also adding a whole lot more monitoring tools. We've got an interesting monitoring suite now that consists of Prometheus and FluentD largely. Both of those allow us to ship both metrics and logs back from our clusters and store them in our central repositories. And then generating more of this automatically. So there's a couple of manual steps right now. As we continue developing, we have fewer and fewer manual steps. And that's about all that there is. So thank you very much. If you have any questions, feel free to shoot them into chat. That's all I have to say. Thanks.
Yep, thank you. Thanks. Guys, if you have any questions, please send them across via the Zoom chat. I will monitor them right now. Okay, okay, there are no questions with regards to Kubernetes, I believe, because we just had a 4-day training on Kubernetes and container security. So I think most of them have already absorbed a lot of knowledge, and now they just need to go back, refer to all the material, and do some hands-on. But thank you, John, so much for this amazing presentation, and we hope everybody's safe and we get to meet each other soon at a physical conference.
Someday.
Yeah. All right. Bye.